Are you seeing the good one or the bad one?
The good one.
Good one. Okay, good. So hi everyone. Thank you for joining us in this session today. It's very nice to see friendly faces and names in this room. Today we propose or we would like to show you and maybe help you in doing a little bit of an exercise with our sustainability assessment tool called MBIOS. I am Cristina Madrid, and I am the coordinator of the team that actually develops MBIOS. Let me just start by saying that it's today's Mikel and I, and actually Mikel did most of the work for preparing this workshop. So it's actually his merit, and and let me also tell you that MBIOS was born as part of the Sentinel project that is about to finish next month. It was the environmental assessment tool of the platform, but that we are continuing the work on MBIOS as an independent or as a standalone tool in other projects, like for example the project Seeds or the project Live. Let me explain why we decided to do Envios, and I'm gonna make a little bit of advertisement for another of the models that we have in Sentinel, which is called Quotidian, and it's not truly a model but a toolbox. But why we decided to do social and environmental assessment of the energy models or the energy systems, and that is because even though we keep talking about sustainable energy transition, in political terms, the truth is that both policy targets and models tend to be focused only on decarbonization, maybe land use, and sometimes, every time more, some materials. But here I'm presenting a work we did in this paper recently published, where we show that people have other concerns, and with people I mean not only policymakers but also modelers, NGO, or even the industry. So we found that concerns beyond greenhouse gas emissions are there, and you can see how, for example, water use, wastewater generation, the loss of biodiversity, soil pollution, ozone depletion are also issues that are of concern. However, this is difficult to include in energy models, right? Because the semantics that you need in an energy model are probably not the same ones that you need to model the environment. So that's where Envios comes at hand. So how does it work? So let's say that we have this very nice work did by Francesco. Hi, Francesco, and other colleagues with Calliope. And then you design an energy system that is efficient, according to certain constraints, most likely including greenhouse gas emissions, maybe economic, and of course you have to meet the demand and maybe land use. So you will give different configurations for that energy system, and we will take that configuration into Envios, and then we will translate that configuration into some processes that we connect. Let me just do this. That we connect with some life cycle inventory data and some other data. Then we have a number of methods inside MBIOS to provide, to calculate different indicators. And you have here a representation of the indicators that we have. A few of them are coming from LCA. From methods known, like for example the recipe method, but some others are coming from another framework called ECEMP, and some other methods and indicators have been developed within the team. Okay, so we take the system configurations, we take the process data, we take the methods. Yeah, we put some methods, and then we have an output that is called indicators, CSV, for which for each of the processes we will have a different indicators. Um, Let me just point out two important things. The first one is that Envios is a Python package, is open access, and is also open source. You can find the repository here on GitHub. The project is called, the community is called Enviro Module, and the Envios package is the one that you were looking for. And if you, during the workshop, you find that you have some issues that we cannot solve, we will really appreciate if you just leave a ticket as an issue there, because it will help us a lot. Then also what happens within Envios is a combination of two perspectives in sustainability assessment. Not to get very deep into that, but one of them is like a movie, what happens before, like raw material extraction and then processing, and then in the end I have my solar panel, and that is the LCA approach. And the other approach is more thinking about the functions that these solar panels will fill and how they interact with other functions like wind production and renewables versus non-renewables, and how this helps to maintain the societies. And that is the MUSIASEM approach. We also, another particularity of BIOS is that we try to make it a co-produced tool. In Sentinel, for example, we were assessing different user needs, and here you have this very nice poster done by our colleagues in EAS in Potsdam. Where we identify the key issues that we transformed into indicators, and then we define the best method to calculate those indicators. But that is not always the case. Sometimes we just take the national climate and energy plans. Here you have a few examples, and then we see, or we take the outputs of different energy models, right? What we try to do is that for deciding which indicator is good to take decisions and what methods we need to calculate that indicator, we go back to the users of the information and ask, and also to do the ranking sometimes. That's about it for my introduction. I just wanted to be a little bit of advertisement again. This is just an example of the type of results that we get from Envios. You have here 6 different indicators for 3 scenarios and 3 storylines. So that will be scenario 2050, 2019, and 2015 for 3 different storylines for a case study on district heating in Sweden that our colleague Nick Martin is going to be presenting tomorrow as a poster. So I invite you to join and ask him the questions and see in depth what Envios can do. We are, of course, facing some limitations. The life cycle inventories that we use are paywall. Today, you are going to be using a manipulation of those, and we ask for permission, so you are fine. But usually, it requires a lot of information that is paywall. So we need to, we are trying to adapt to open data repositories, or maybe creating our own processes as a mix of others that people can use. Also, we have different semantics to energy system optimization models. So we are creating dictionaries. You have the friendly data semantic, which is already included in Envios, but we are working, for example, in a dictionary to the Envios IAMC nomenclature. We are lacking geographical reference, and that's actually part of the PhD of Mikel that he's going to be doing in the next years. And to do that, one of the ways that we are working on is integrating with another software, a very nice a suite called Brightway. And also, we don't have any option for valuation of environmental issues or for changes in technological innovations that we are working on with Jakob, actually, who's right in the next room. So just to give you an idea of what the further development of Envios is going to be, Sentinel is almost gone, but we have Project Seeds running for another long year and a few months. We have the Project Leven working for 2 more years, and Just Win for All, which is a Horizon Europe project that we are starting next month for 3 more years. And here I made a summary of the things that we are going to be working, important issues, important items like the geographical reference, and uncertainty indicators as well. Let me just say that I am just a representation of the team, but this is some people who are currently working or have worked in the past, like Marie, Joaquin, and Laura in the development of Enbios. And if you have, this is just a few of the institutions we work with. And if you have any questions, you can feel free to reach us. And I don't know if there are any questions. Maybe I was too fast. We can always talk to the imposter session more calmly. But I don't see any questions or any issues or concerns. So what I wanted to do is to give the microphone to Miguel now, so he can start explaining you what we are going to do.
Okay, so I will share my screen. Um, I hope you can see it well. Okay, so now I will explain a bit what this work session will be about. And the outline is this one. First, I will explain how we define energy systems in Enbios. Then I will show how is the Enbios structure and how Enbios works internally. Then I will explain briefly how to prepare the input data file and how to prepare the base file, which is the mother file, which contains all the information that Enbios needs to be run. And then you will jump in and we will work on a simple exercise just for you to test Enbios. And after that, we will comment the results and I will show you some possibilities, not just for this simple exercise, but other options that we have with Enbios, much more complex. So essentially in Enbios, the energy systems are defined in what we call dendrograms, which are three showing structures. And this is the dendrogram we will be working with, which contains the energy system in level n, the electricity production in level n minus 1, and then we included two technologies, which are photovoltaics open ground and wind onshore, which are linked to the electricity production. So in this simple case study, we will work with this dendrogram. And essentially, as Christina explained before, the dendrogram can come or be given by an energy system optimization model, or we can do it by hand by introducing policy targets. So this is another example of a dendrogram, just to show you that dendrograms can be much more complex like as this one. For example, in this case, we have a dendrogram based on PENIEC, but the whole energy system. So for the electricity generation, we have the operational flows and the infrastructure. And as you can see, many more technologies are included here. Coming to how Enbios is structured and how it works, the central file that will tell Enbios which calculations to do is the base file. And in the base file, we define the dendrogram, some indicators, and some reference data. But this base file also requires some input data coming from other sources. For example, life cycle inventories of the technologies included in our dendrogram. And we have several commands within Enbios that change the structure of this external original data and converts it into some data that Enbios can read easily and that can be incorporated into the base file. Also, we have LCA implementation methods, and these are converted into LCA methods and characterization factors, which are needed to be included in the base file. And once the base file is prepared, we also need the input data, which is the amount of energy produced by each technology defined in our system, and the scenarios coming from Calliope, which is the tool we use more typically, but also we can define scenarios ourselves and indicate energy for each of the technologies included in these scenarios. And once we have these two inputs, we can run MBIOS and have some results. So in this case study, just for simplicity, all these previous steps that should be run to prepare the base file have been prepared for you. And we will give an already prepared base file and some also prepared input data, but you will be able to run MBIOS in this case and obtain some results that we will analyze together in the end of the session. Let me just show you how an input data file looks like. It has to have this structure. It's a CSV file, which contains the scenarios that you want to analyze, the technologies. In our case, it will be wind onshore and open ground photovoltaics. The locations, in this case, we don't have any, which carrier it is, the unit, and finally, the values. So the amount of energy for each of the technologies and each of the scenarios. And also, let me show you how a base file looks like. In a base file, we have lots of sheets, and all of them are important, but most important ones are these two: bare processor stop levels and bare processor simulation, and also the scalar indicators. So in bare processor top levels, what we do is define our dendrogram, and as you remember from here, in our case, we have level N, energy system, and level N minus 1, electricity production. So here we introduce the energy system and the electricity production, which is linked to the energy system in the level N minus 1. The next sheet is also very important, bare processor simulation. And in this sheet, what we do is connecting the technologies. So this level to the level, the previous level, in this case, electricity production. So as we commented before, we have in our case study wind onshore and open field photovoltaics. So we specify that on the processors column. Then we reach the simulation variable, which here we tell MBIOS where the electricity values from these processors can be found. And this is the input data file that I talked about just previous to explaining the base file. Here we specify the parent processors, so these technologies to which processor are linked, in our case, the electricity production, according to our dendrogram. And finally, we reach two important columns, which are the ECEMP22 file name. In here, we have to put the name of the SPOLT file coming from ECEMP22 that contains the life cycle inventory of this technology. So this is the SPOLT file name of the wind onshore life cycle inventory in ECEMP22. And this is the name for the photovoltaics open ground. And finally, we reach the simulation to ECEMP factor. And this is to match the functional unit contained in the life cycle inventory with the unit that we give to the system in the input data file. So in this case, we are providing the electricity production in terawatt per hour, and the functional unit of the lifecycle inventories are in kilowatts per hour. So we have to tell MBIOS that there is this mismatch, and with this value, it will correct it. Finally, another important sheet is scalar indicators. And in this sheet, what we do is telling MBIOS which indicators we want to be analyzed. So in this case, and in the case study you will work on just when I finish, we define some indicators from the LCA method recipe midpoint H, and we have a specific function that we can, a specific command that we can run in MBIOS to generate this sheet with indicators coming from typical LCA methods. And now I think that Eduardo shared with you in the chat a link, and in this link you can find the guidelines to start working on the case study. So just if you can confirm me that you can enter into this link and you see the guidelines. Yeah, Eduardo shared it again. So the first thing you will need to do is to install all the required, the first thing you need to do is to go to the second title, which is where you can find the necessary materials in page 2 of these guidelines. And here you have a Google Drive folder where you will find all the necessary files to follow the session. So if you can go there. Now download all the files that are contained in the folder named files in this Google Drive file. And you will have in your computer all the necessary files to follow the session. Vale. Cristina is showing the Google Drive file. So you can download that. And after that, you will have to follow the instructions for the software requirements and the installation of necessary software to run MBIOS. Which is in the guidelines that Cristina will show now. So start following these steps, and just be aware that this is the first time that someone outside the team runs MBIOS, so some errors and problems might appear. And if this is the case, just write in the chat what is it about, and we will try to fix it as soon as possible if we have the means. And if someone is stuck with any of the steps, just reach us and we will try to help. Does someone have any questions so far?
I just wanted to I just wanted to show you, for those of you who are not modelers, this is where you can download Anaconda, and it recognizes that I have Windows, so it will appear Windows, but probably if you have other operating system, you will see the download for your operating system. And then takes like a couple of minutes depending on your computer, but you can also, yeah, so if you have it installed, you can just skip this step. So this will be this step here, installing Anaconda. And this is how you open an Anaconda terminal, in case you don't know it. If you just look for that and you see the Anaconda prompt. It should look like this. Can I ask how people is going? So if you are okay, can you just say okay? And if you are lost, you say, I need help or something. Nothing at all. Not even okays. Okay. Vale. Sorry, I don't see the chat. I'm assuming, I know that this is going to be boring for some of you guys, but probably those of you who are familiar with Python can simply jump to install NBIOS, create an environment, which is this step here. And for those of you who don't know how to do it, you just have to copy and paste. And then it will create the environment and BIOS for you. And within the BIOS environment, what we are doing is to actually install the packages, both of them, Next Infosys and BIOS, and a few others that are useful for visualization, the Seaborn, and for the interactive exercise, that is the Jupyter Notebook. Is anyone already in the Jupyter Notebook? I mean, I'm looking at Cruz and Francesco and Miguel. A few others probably are already in the notebook. Hmm. See, then I will stop sharing.
So for those of you who already have everything installed, and this is how you launch the Jupyter Notebook, you have to go to the path where you have downloaded all the materials for this simple case study, activate your environment and BIOS, and then launch the Jupyter Notebook with this command, Jupyter/notebook. If someone is already in the Jupyter Notebook, you can start reading the materials. We wrote them just for them to be self-explanatory, but I will try to guide you through it when most of you are already there. But those of you who are already in the Jupyter Notebook, you can start to explore the materials. Note that you can also check the base file in case you are waiting for the others to be in this step. And there you can check if you can recognize in the sheets I explained before all the information. And if you have any doubts, you can ask us. Apart from Cruz, um, is everybody doing okay, or does anybody need a hand with something?
It's actually difficult to see if you guys are okay because we cannot see you. but Jacob seems fine. David, you seem quite fine as well, and you're muted, or at least I cannot hear you.
No?
Now we can listen you, David.
We hear
Well,
you.
if you drop the microphone, you're muted again for us.
Okay.
Now.
It's like, okay. Yeah, I ran all the commands to set up the environment, but once I'm in the notebook, I can't import environments, which seems weird. So like the first cell doesn't work.
Do you mean the first window with the imports?
Yeah, the environments, like the first import, like from environments, import environment, from environments, bin script, import environments.
Did you get any error message when you were installing, David?
I didn't see any. I could check again. Yeah, let's check that again. Maybe. Thanks so far. I tried it.
Can you is it an option for you to share your screen? I don't know if you can.
Let's see. I think so. Yeah. Okay, you can see it, right?
Yes, it seems that Envios is not
Installed. Yeah.
installed. Yeah.
I'll check again if I rerun the installs. Maybe it's just something happened and I didn't notice.
Okay.
Hi, Christina. I have a quick question.
Hi, Miguel.
Yes, just managed to get the notebook up and running after installing in BIOS, but I'm getting some error. So maybe I can just show my screen if that's possible. And yeah, um, yeah, it's here.
Can you go to the bottom of the message
Yep.
and specify error? Miguel, for what I've seen, it doesn't ring a bell right now. Can I ask you to please copy this and leave it on GitHub? Let me just copy the
Yeah, I can do that.
here in the chat. I just left the GitHub issues, so if you can copy there, maybe it's easier to have a look.
Yeah, perfect. Thanks.
You're welcome.
Miguel, you are still sharing your screen. It's not a problem, but just for you to know.
Great, thanks.
David, how is it going for you? Is it working now, or do you still get the...
Yeah, the imports are worked. I'm now doing the file paths and the YAML.
Good.
And because in the YAML file, they are built as strings, right? So with the quotes around it, right? Paths.
You can, yeah, it works both ways. You can
Okay.
put it with quotation marks or without. It will work.
Jakob, I see you thinking. Are you good?
Yeah, actually, Anaconda is still installing. I don't know, maybe my internet connection is not so good here. So I will just follow your. I will just follow the next processes that you will present. I'm not sure what's happening.
Okay, no worry. In
So I'm
just a few
I'm
minutes.
just about to download Anaconda, so it's still downloading and installing.
This happens sometimes.
Yeah.
But in few minutes, I will show the results you could expect, and then some variations of that. So don't worry. At least you will get a sense
Great.
of. Yeah.
Thanks.
I have another question about the YAML file. I'm getting a scanning error. So, apparently, when it scans maybe I just share the screen. That's okay.
Can you say that again, David?
Okay. I'm getting another error when scanning. Apparently, when scanning the YAML file. So maybe I can just share the screen if it's okay.
Yeah, sure.
Careless. So I ran this command, and this is apparently the root of the error. I'm not sure if it's something with the path that I have to quote or something.
Can you go to the cell for a moment?
appear?
Never seen this error before.
It seems to set something in the YAML file.
Yeah, if you can copy that in GitHub too, we will have a look at that.
Yeah, okay. Cool.
It's actually a pity that this is online because it's a typical thing that it's super useful for us, and we just want to say thanks a lot for this time. And then if we were in person, we can invite you to a beer afterwards. But because we are online, we cannot. So sorry, David. In the next conference. But this is super useful for us. I also haven't never seen that error before.
What do you think if I follow with some explanations about the results you should get? Would that be okay for you, or you want to keep trying?
It's because we only have 30 minutes left, just to be sure that we show something, and you can always try all the time and let us know if you guys like. Yeah, good. Thanks.
Yeah. So I don't know if I'm sharing the screen. No. So now you saw that sometimes when working with development tools, things can get messy pretty easy, and we wish these errors will be fixed soon. But thank you very much for the info, because it's very useful for us. But now I will try to show you what results you could expect from that experiment, and these are they. If you remember when I showed you the input data file that we were using three scenarios: current, tendential, and target. And we had two technologies: wind onshore and open field photovoltaics, and several input data for each of these technologies. And as we specified in the, let me show you that, as we specified in the base file, in the scalar indicators, here, I didn't tell that before. Here we have a column. If we use this symbol, MBIOS won't read these indicators. So in the case study we are following, we are telling MBIOS just to run the results for the climate change indicator, fossil depletion indicator, natural land transformation, and water depletion, which are those which don't have the muting symbol. So this is the results we should get, and we are looking at level 0 of the dendrogram, so the whole energy system, And as you can see in the current scenario, which is the one having lowest energy inputs from wind and photovoltaics, the climate change impacts are the lowest. In the tendential, which is the scenario we would be if we follow the trend of wind and open photovoltaic installations we are on now, we have a little bit more of wind and open ground, and therefore the global warming potential is also higher. And for the target, when these two technologies are going to be to have a lot of importance in the energy system, the global warming potential is much higher. And this is because when we consider the life cycle inventories of these technologies, we account for not only the use, but also all the necessary inputs to all the raw materials necessary to construct the infrastructure, and also decommissioning the infrastructure once it reaches the end of life. In the case of the fossil depletion, we have the same trend, more impact in the target and tendential than the current scenario. Natural land transformation is an indicator that explains how many square meters of land are going to be transformed into some of these technologies. So now our natural land, but it will be land used for wind and open field photovoltaics. And yeah, that's why it's a negative sign. And you can see that also in the target situation, we will have much more natural land transformed. And finally, looking at the water depletion, we need also a lot of water during the whole life cycle of these technologies. In the case of the target, 1 to the 11. These are the results that you could expect from this simple case study, but with MBIOS, we can run other simulations. For instance, we could inspect, instead of the whole energy system, the technology level. So this is the contribution of each of the technologies to the global warming potential that in the simulation we run. So as you can see, for instance, in the current scenario, we are generating 32 terawatts per hour of wind and 8 terawatts per hour of open field photovoltaics. So photovoltaics are less, but the emissions are more or less equal. This means that the emissions of the open ground photovoltaics are much more in the whole life cycle than those of wind, for instance. But in the target, we can clearly see the same tendency, because both technologies have more or less the same amount of energy, but the open field emissions are much higher than those of the wind. And this is the kind of results we can expect after running MBIOS. So another thing we could do is, instead of focusing on that 4 indicators, we can run the MBIOS for other indicators, and this could be done in the scalar indicator sheet in the base file. And here you have results for other indicators, for example, agricultural land occupation, freshwater ecotoxicity, and yeah, freshwater irrigation, you name it. Another thing you could do is, for instance, modifying the input data, just to speculate what could happen if we decided to have more ambitious renewable targets and increase the input data for the wind and open field in 2030. So instead of our target in the Spanish PENIEC being 70, as we saw before. If it was around 100 or 150, what would happen? And as you can expect, the target scenario, in the target scenario, we can see much more global warming potential, fossil depletion, natural land transformation, and water depletion. And it would be really nice to compare this if we had not just renewable energy, but also other technologies like nuclear or coal, and see the difference between the technologies. And this is something we could do by running other tests in Envias. Other possibilities that we can do is define as much scenarios as we would like. So for instance, here what I did was adding 2 more scenarios in 2050, and yeah, put any numbers here, and just for you to know that we could introduce more scenarios and define them as you would like, and then inspect the results as we have done like before. Finally, I will show you some results from a case study we are working on. More concretely, it's Alex, our partner, that cannot be here today, but he has been working in the SEEDS project in Portugal. And in this project, the data is coming from Calliope, which is an optimization model. And we have much more technologies, so 36 technologies instead of 2 technologies, which is the case study we are working on today. And also they introduce locations. So they divide Portugal in 2 regions, and then each of these regions is divided into several sub-locations. So they allocate each of the technologies to these locations and introduce the produced energy in those locations. So this case is much more complex, and I wanted you to see that we could run complex scenarios with Envios. And this is the kind of results that Alex got with the preliminary data from Portugal. And he ran it for all the levels in his dendrogram. So he can see that, for instance, what he defined as storage technologies has much more global warming potential than the generation technologies. And he was looking at the different levels in the dendrogram. So here we can see that, for instance, CHP biofuel is generating more emissions than hydro run river technology. So as you can see, we can define very complex systems and try to analyze the data at all the dendrogram levels and try to raise conclusions from that. And that's all from our part. Remember, you can contact us about the workshop, about these results from the preliminary tests in Portugal in the SEEDS projects, or just about Envios and the projects that Cristina is running. And also remember that you can look at the GitHub repository, and if you have any comment or issue, you can post that whatever you like. And now, if you have any questions or doubts or comments or things you think that could be improved in Envios, we would be very happy to hear that from you.
It's already perfect. There's nothing to do.
I just had a question from Christina from your first presentation. You mentioned 2 perspectives in the indicators. First, the other one was this
CSM. Yeah, you can. So for sure, is one of I think life cycle assessment perspective is the easiest to grasp, right? Because it's clearly the value chain of the technologies, and that's how we can distinguish, for example, between building new infrastructure and operation. And we are coming from a field called industrial ecology, where social metabolism it's a big approach, and basically it's the same idea that you can get from biological metabolism, right? So if you have a cell that needs nutrients and also has some waste, so the societies have the same dynamics, you can say that way. And then if you look at your body, for example, your brain is not very heavy, but it consumes a lot of energy, much more than your muscles. But the total of energy your brain consumes is probably the same than your muscles, because you have so much more muscles in your body. So this is the type of things that we will look at, the social metabolism. And then we have indicators like how much, for example, how much water depletion we create by each hour of operation of a certain technology, or how many jobs you will need to operate a certain technology, which is more looking at the social aspects. The acronym, it's a long acronym for a long name. I just write it in the chat. It's called MUSIASEM, the approach that we are using, and that stands for Multi-Scale Integrated Assessment of Socio Ecosystem Metabolism. And we ran another project here at UAB that we coordinated. That's called the Magic Project. And during that project, we started to create the next Infosys, which is a NIST that we call it, friendly, which is the part of, is actually now inside Envios. It will be the part of Envios that does this metabolism assessment. It's just that Envios simply got this, the next Infosys for the metabolism assessment, and then we add the life cycle assessment and combine them both. So the difference, for example, between Envios and CIMA Pro or any other software that calculates LCA is that with that software you get to calculate one system, like or one technology or one system with a mix of technologies for the full life value chain, but you cannot really do these social metabolism calculations. That's this is quite special, and it's also the trickiest part, because in this tree that we create, we see, when we do the social metabolism assessment, we see that sometimes you find emergent properties. That means that the sum of the lower level is not giving you the same that the total of the upper level. Like if you sum up level n minus 2, it's not the same that the receiving processing level n minus 1. And that happens not so much with energy production because you sum up, but it happens a lot with environmental impacts, for example, or social impacts. But I have to admit that part is still in process. And for example, right now, Jakob, that you can see, has a similar background than us. He's actually a colleague of Sentinel from GRASS, and he's here because he does general equilibrium models. I think you have a workshop tomorrow, no, Jakob? Or a presentation as well. And we are working together and trying to see how to integrate technological change in Envios, for example. So it's all to do, David. If you want to come and join and work for that, you're welcome.
It's all very interesting. Yeah. I'm just starting with I'm started at PIC in Potsdam, and also working on LCA and coupling it with our Remind model, the integrated assessment model. So that is this workshop you just seemed to be the right one for, really popped into my eyes.
So then let me tell you that Peak was one of the partners of the Magic project, where we created Next Infosys, actually. So there is that. And then Cruz, I don't know if you didn't get to do anything, right? But and you're probably just trying to organize some of the stuff because Cruz is part of the organization team. So I don't know if you guys.
Basically, preparing my presentation tomorrow.
No, that's really bad. How can you do that when we're doing the workshop? No one does that. Who does that? No one does that.
The main problem is that I have two because my colleague has get out, so I have to make a two presentation for tomorrow. But yeah, I have
Um,
been taking note of more or less a couple of things that are relevant for what I understand. And I will use a recording also, and well, I have to check because Conda and Pip are not welcome in my operating system. So yeah, I
which
have to.
operating system is that?
I'm using Gentoo, but almost all the system is based on Python, so they don't really want it to mess you with the Python installation.
Okay.
So you need to do certain things to install things. And yeah, I was not aware that I need to take care of that before the meeting.
Sorry, yeah. Like we will note that for other workshops that we run that we need to send this in advance. And then we have Miguel. Miguel, are you in Aalborg? How did it go?
Yeah,
Did you manage everything?
no, I moved to Norway after we saw each other in Greece. So
So Denmark was not northern enough. You really
no, it
needed.
was not. It was not cold enough or dark enough. So yeah, but now I'm
Nice.
using Times
Thanks,
also.
David.
Yeah.
Nice talking to you.
Yeah, same. Ciao.
Did you manage to install it or run it, Miguel? Or
No, I got that error. And I was looking a little bit in the Stack Overflow, and I think it's something with the installation. So I'm gonna actually try with my other computer. I also have more strict installation guidelines with the new job, so I think maybe it's something related to that. But I'll try again.
I have to tell you that I have been running it for 2 days, and today I just did another run, and we were panicking this morning because I got a permission denied error, and fortunately we discovered it was only my computer. But yeah, so I mean, we have to admit it's quite at the beginning, right? So these things still they are probably not as polished yet, but
But
that's why
it's
we do
good.
these
But
workshops.
it's good for you because then you have a lot of us as guinea pigs that can actually test it
Things,
and see where
yeah.
it fails.
Yeah, that's what I said to David, no? That usually when you do this and it's not that much people, then you say, okay, let's go for a beer. And like we invite you to a beer, guys. Thank you for your time. But now we cannot do that. So maybe for the next conference.
Yeah.
And then Chile, I don't know if you are there or not, if you had any issues or might not be there. Okay, then. Well, um, are there any more comments or questions? I don't think there is any. I think people is just gone home for dinner, probably. Especially in the northern countries.
I have
Um,
one, Christina. Maybe I was wondering how do you guys deal with the inventory databases and like future energy mixes? Because I guess in some cases that could be a bit of a challenge, especially if you consider a renewable future, and a lot of them have more like a
so
current setup.
I'm so happy that you raised this issue. No, so the thing is that when we were got actually when we in the work of integration with Calliope, we realized that we were getting emissions, whereas Calliope was setting emissions to was forcing emissions to zero, right? And then two things happened here. One thing is that Calliope was not taking into account life cycle emissions, so they were only taking into account direct emissions, and they were assuming that the industrial system would be already fully based on renewables, so the value chain will also not pollute. Now, that is not the case, but that was what's happening. So we started discussing on how to include technological change, because that is what happens, right? So the inventories in Envios, we don't touch those. So the inventories from EcoInvent, we just use the same ones for the baseline scenario than for the 2050 scenario, or the 2030. And while it is, I think, in my view, is really unrealistic to assume that by 2030 all the industry is going to run on renewables. It's probably the way to try to go, right? So what we are doing now, that's why Jakob is here, we are trying to use the changes they have in their general equilibrium model of the productive structure of the economy, try to use that to change the inventories from EcoInvent, and then run those. And then run Envios with that changes included. But it was something that we didn't realize, because we created Envios practically from scratch, right, in Sentinel. So it was a lot of work, and when we had it all together and we saw the results, is when we realized actually that that was an issue. But Johan is very interested in doing this. So, and because we have some other projects with Stefan, we are also trying to work on that. But yeah, so basically the answer to your question is we don't do that right now. But hopefully when Jakob leaves in 3 weeks, we should be able to do something with it.
But it's very interesting because then you're kind of closing a little bit more the loop of the whole interlinkages, actually.
Yeah,
Also,
it's just a pity that Sentinel is finished right at the time when all the machine was up and running and everyone knew how to work with each other and everyone knew. Then the project is gone. Now, Jakob, I was just saying that it's a pity that now that we all know exactly what inputs and what outputs others can use as inputs and how to use them and all that, the project is over. But I guess that's why we got a 6 month extension anyway. But still, it's not enough time.
But
Maybe
in the end,
Sentinel too.
yeah, but in the end, it's also a learning process for ourselves as well. And I mean, we reached a lot, so we can now see where the linkages are, where are the problems, but also where are the potential merits of linking our models. So I think for ourselves was a very nice project. It was really a laboratory, so to speak. Yeah. And
Yeah.
it's a pity, of course, that's already ending. Yeah.
There is always Sentinel too. Let's see if we can convince Tony for that. So guys, it's 3 minutes to go, and I don't want to take you here more time than necessary. I just wanted to say big thanks to Mikel, who has done a lot of work for the last 2 or 3 weeks to prepare this workshop. So, round of applause. And thank you, Eduardo, also for all the organizations. And I just give it back to you. I don't know if you need to say anything else before closing or if we close.
No, not much else. Thank you all for participating.